Hi, everybody.
Okay, good morning, everyone. So we've started our webinar today with Zach Schildorn. I see people are signing up, so we'll wait a minute or two for people to sign in. And I'm also going to start using the chat. Okay, so I guess we've got about 10 people who've joined in right now. More will join in. So let me start by some introductions. So welcome everyone. My name is Vishal Sachdev. I'm the director of the Illinois Maker Lab and also an instructor on the Coursera course on 3D printing applications. And my guess is most of you are joining us through that course because we advertised this webinar there. But this webinar is also live on Facebook. So I guess when people join on Facebook, welcome. And we are, we have a chat interface as well. So please do introduce yourselves. Where are you from? What are your interests while the webinar is going on? So for those of you, I think most of you would know where this lab is situated, and I guess where I'm coming from in terms of the course. So I'll leave that out. If you're interested, you can look up on Coursera and search for 3D printing. If you haven't seen a course, you can find it, or just find us on 3dprintingprofs.com, where we have all the information about our courses. So I'm right now streaming from the Maker Lab. I'll give you a little walk around and show you our lab as well. So that's our sort of printer farm. And if you have, this is sort of our biggest print we've done. That's a 6-foot max, we call it. That's actually the scan of one of the founders of Voodoo Manufacturing. So that's one of the most fun projects I guess we've done there. So with that, I'd like to introduce our speaker for the day. So Zach Schildorn is a partner at Lux Capital, also a board member, and he's already in our course. So I interviewed him about 2 years back. And so many of you who've taken the 3D printing applications course would have already heard an overview from him, but 3D printing is changing every 6 months. So that's now a 2-year-old perspective on, the money flows in this industry. So I wanted to get an update from him, and there's been some new movement on the investments that, his firm has done, but I think he brings in a perspective about the entire industry. So thank you, Zach, for taking the time to chat with us and our students. Let's start with, an introduction on you and, what your firm does.
Thank you for having me. So I'm Zach. I'm a partner at a venture capital firm called Lux Capital. And we focus exclusively on investing in futuristic science and technology companies. So we're not focusing on social media or online gaming or apps or analytics. It's everything from nuclear waste cleanup to surgical robots, 3D printing, launching satellites into space, computer vision, a lot of amazing technology that is often inspired by science fiction, which 3D printing very much fits in. I've been passionate about 3D printing since 2010, 2011, and we made, as a firm, our first investment in the space in 2012. We've invested in over 3 companies. We've invested tens of millions of dollars, and sort of keep a close ear to the ground on what's happening and have an insider perspective from what we see in our own companies. I've also dabbled in some of the public market shenanigans in 3D printing, which has been fun, and watching that grow and shrink and grow again. And it's been a very dynamic space. And I think it's really important space to watch, because over the coming 5 to 10 years, we are going to start to see a major shift in how certain types of goods are made. I do not have a 3D printer farm in my office, but I do have an aquarium,
Nice.
which does have a 3D printed toilet bowl inside, although it is
nice.
completely overgrown. And by the way, this is really meant for all of you, the panelists. This is not ego gratification for me, or all of the attendees. This is not ego gratification for me. So if you have any questions at all, feel free to chime in. I think we got about 30 minutes, so I'll give you a quick overview. So I don't know if many people are familiar with the Gartner hype cycle, but Gartner is a consulting firm and they focus a lot on technologies and emerging technologies. And they sort of coined this term, the hype cycle, which is sort of a graph that defines people's expectations around a particular topic. And it's typically a bell curve started, an inverted bell curve that looks like this, and then it goes way down and then ramps back up over time. And what they call those different peaks and valleys are really, the technology trigger. So a moment in time where something happens, where an idea goes off in people's head or an industry realizes that something important is changing. And all of a sudden, a lot of excitement. People really start paying attention. Interest increases over time. Valuations of companies might rise. Stock prices might go up. And you hit this point, which is the peak of inflated expectations. And that's probably where we are right now with things like artificial intelligence, with things like Bitcoin or blockchain today. We're sort of at or beyond perhaps that peak of inflated expectation where perception is ahead of reality. I think we were there with 3D printing 2 or 3 years ago. There was a lot of excitement in the space. Everyone was talking about it. Stock prices were going crazy. People were talking about printing cars in their houses, putting printers into space, making things anywhere, making everything with 3D printing. It was insanity. It was at the same time great for the industry because it brought a lot of attention and interest and new entrants. A lot of entrepreneurs realized that there was something important happening. They decided to start businesses. Big companies who had nothing to do with 3D printing or with some tiny division inside all of a sudden started investing heavily. And you've seen all of these things play out. HP, which is a huge traditional printer company, split in two, and one half of the company is highly dedicated to 3D printing today. It's a major component of what they're doing. GE, the world's biggest manufacturing company, or one of them, decided that 3D printing is part of the future and acquired several companies and made many announcements here. And you're seeing many other companies follow suit. MakerBot, this startup that made desktop 3D printers, got acquired for $400 million, which is a lot of money for a startup that makes hot glue guns that are on robotic gantries. So it's a pretty exciting time. And then all of a sudden, boom, stock prices drop. People are like, where's the money? Why isn't 3D printing everywhere? Why don't I have a 3D printer at home that is printing me off wine glasses and spoons and anything I can imagine? And that is called the trough of disillusionment. And it's sort of a dark period in time where it's harder for companies to raise money, where the press isn't talking about it as much, where maybe the sentiment turns a little negative of what happened to 3D printing, or why isn't 3D printing more prevalent, or here's what was wrong with everybody's idea about 3D printing. And the reality is, the news cycle and the expectation cycle, and I think it's largely driven by the impatience of people, often is faster than the actual progress of technology. But all the while that technology is progressing, usually linearly, super linearly, or exponentially. So while expectations are going like this and then reaching sort of this plateau of productivity where things are rising, the actual technology itself might be doing sort of a more linear curve or a more exponential, consistent curve upwards. And what really excites me right now is sort of, we're at this point where not as many people are talking about 3D printing, not as many people are focused on it as they were 2 or 3 years ago, but what's actually happening in the real world is more amazing than has ever existed in the past. And there are really important decisions being made by very large organizations that are going to impact the future of how things are made. And so taking a step back, what's exciting about 3D printing? It's not just 3D printing, but I would say all digital manufacturing technologies, but 3D printing has some particularly interesting characteristics. It's this idea that you can go and have a complete digital thread from idea to production, and then perhaps even beyond, feeding back into that design cycle, getting feedback on how parts perform in the real world. Historically, that wasn't possible. To have an idea, you would draft something up, and a talented machinist might be able to craft that, an artisan. Then we started getting more sophisticated design tools and more sophisticated machines. And today, most design is done with software. It would be crazy to see someone, hand sketch out their next product. So most design is done in software, but there's still oftentimes a gap between that software design and the end product that is created. There are many different manufacturing steps and tooling that needs to be created. Even if you're CNCing something, you oftentimes need to, which is a computer controlled machine, you oftentimes need to have a special tooling or jig made to support an object or hold it. For injection molding, it's a completely separate process. It's not really digital at all. But 3D printing has this amazing characteristic where you could literally just press print and theoretically have that object in your hand a few hours later. And it also has this amazing capability to create geometries that are inaccessible to other types of manufacturing technologies. You can have complex internal geometries. You can have very, very convoluted organic shapes. This is a 3D printed object right here. It's just an artistic demonstration, but you can see all the detail that's created in that object. Try to imagine making this any other way. You couldn't injection mold this. You would never be able to get it out of the mold. You couldn't really CNC this. You'd have to get a tool bit like way up in there to be carving out. I mean, historically, this could only be handmade, and this is just a proof of concept, an artistic rendering. But imagine what happens when you could have perhaps cooling chambers in a fuel injection nozzle or a jet turbine blade, or have a shape that sort of mimics something more organic from biology that has ideal parameters for strength and lightweight. And this is what's really capturing people's attention. And at the same time, you've had a lot of advances over the past few years in what's possible. So before, what may have been only plastics that you could print or a limited variety of materials, now there are companies, including companies we're invested in, that are printing incredibly high performance metal alloys, the type that are aerospace certified, that are medical certified, that could go in human implants, that could be parts of aircraft or automobiles or motorcycles, or who knows what kind of future craft that we're going to create. And I think engineers are really starting to rethink what's possible, because you can imagine this closed loop, as I was alluding to, between not just thinking, okay, here's this bracket I have to make, how am I going to go design it? But okay, here's what I'm solving for. Let's eliminate all of those prior constraints around design, around manufacturing process, and ask myself, what is the ideal shape? What is the ideal object that might be the lightest weight or the highest strength or have the most vibration tolerance in a particular dimension? And let me try to create that shape. And wait, maybe I'm not even qualified to make that shape. Let me have a computer create that shape. And let me have a computer simulate how that shape performs. And let's actually print that shape, test it, take the feedback, and go design it again. And all of a sudden, instead of having a design cycle that is months or years for products, companies and engineers can start tinkering and create design cycles of days and get to optimal designs that look nothing like what we've seen before and have all sorts of secondary benefits. The other advantage of 3D printing, of course, is you have no tooling. Traditionally, when you manufacture something, you have to make a tool, and that tool is expensive and there's a lot of upfront costs. And then you're making that part, over and over and over and over again. It's like trying to find that automobile part from 10 years ago. They made tens of thousands, hundreds of thousands, and there's a bunch extra lying around. But if you need one extra part and you're in some part of the world where you can't find that part, you're out of luck. There's not a lot you can do. But if that part were designed with additive manufacturing and produced with additive manufacturing, and there was an additive manufacturing center nearby, there's no reason that file couldn't exist and you couldn't just load up the file and print out that part. So it can change something like the spare parts business. And we have companies that are working with customers like Caterpillar. Caterpillar has a 30-year brand promise. They want their machines to work for 30 years in the field. There are a lot of parts on Caterpillar machines and they go through a lot of heavy use. What happens if you're in Zambia and one of those parts breaks? How do you get that part? They're going to have to find it in a warehouse, maybe in Europe somewhere, ship it out. You're down in the field for 5 days. But if there's a metal additive manufacturing machine nearby, you could have that part in under 24 hours. And that's one of the promises of 3D printing. design on demand, parts on demand, iterative design cycles that are much faster, new types of geometries. And the limitation to date has really been capability and cost. Cost is related to a few factors. It's, of course, raw material cost, its speed of the machines and how quickly things can be produced, its expense of the machines, the capital equipment cost, it's the availability of those machines and how widely used they are by industry. And capability, there were a lot of materials that could not be used. There were many machines that had limitations on strength or parameters, and all of those things are changing. We're invested in a company called Desktop Metal that I encourage you to check out. I might show a video from. But what they're doing is going to change how metal parts are made. They started with the end customer challenge they were trying to solve, which is how do we use super high strength, well understood existing materials that engineers trust, and how do we make that cost effective to use at scale? And that's exactly what they're trying to do. And they're combining that with a lot of amazing software that's going to let them produce really cool products that hopefully you'll see in the market someday soon. So maybe with that, we could go with, I don't know, are there any questions yet, Vishal?
I haven't asked, so all those who are viewing, please ask your questions in the chat. I think what would be interesting is to see Desktop Metal, and because that's, I guess, the new kid on the block in terms of metal 3D printing. To tell us a little bit more about how practical that is, or maybe let's see the video.
Cool. Let me share my screen here. One second. Share screen, share computer sound. Okay, let me know if this works. So this is Desktop Metal. We are investors in this company. We are early investors. It was founded by a bunch of MIT alums, including some of the chairs, the material science departments, including Rick Fulop, who is just an incredible individual. He founded A123 Systems, which was one of the first advanced lithium-ion battery makers, and took it public. He was a venture capitalist for a period of time, invested in the 3D printing sector, and got so excited about it and saw such a big opportunity that he decided to go build this company. He's taken a very customer-centric approach, and the company's building two systems. One is a studio system that is meant to be in engineering offices. It's super accessible. It doesn't require any crazy gas venting systems or specialized power. It's something that you could roll into a regular doorway and be printing real metal parts and fusing those parts inside of an engineering office to prototype. And from that, you graduate to the production system, which is what I'm going to show you now, which is meant to be the world's fastest, highest speed, most affordable metal 3D printing process. It's an entirely new process. They have accepted tens of millions of dollars of bookings for this from some of the biggest companies in the world. They'll be shipping this production machine this year. It's in production. It's very exciting, and there are a lot of changes that are going to come. So I'll show you how the production system works, and then I'll help show you a little bit about what Desktop Metal is thinking in terms of what comes next. Let me know if the sound plays on this. Just give me a thumbs up.
Sure.
Metal 3D printing could change much of the world around us if it was fast enough and cheap enough for mass production. Introducing the production system, powered by single-pass jetting. At up to 100 times faster than laser-based systems, it's the first metal 3D printing solution for mass production. It works by combining 2 powder spreaders and 1 print unit into a single-pass system to both spread metal powder and print. Unlike existing metal 3D printing, there is no wasted motion with single-pass jetting. A single pass starts in the powder spreader, where a metering system deposits metal powder, and a compacting system forms a layer, as thin as a human hair. The print bar follows, jetting droplets of a binding agent. Millions are jetted per second, binding metal powder to form high-resolution layers. Anti-sintering agents are then deposited, making it possible for supports to fall off after sintering, saving hours of post-processing. Once the layer is dried, the process repeats itself. single-pass jetting is bidirectional. We combined all the necessary steps for printing into a single pass, so that whenever there is movement, there is printing. This makes it possible to print parts in minutes instead of hours. Once printed, the brown parts are densified in a microwave-enhanced furnace. It combines conventional heating with microwaves to speed up sintering. A closed-loop thermal control system regulates temperatures in real time as parts are heated to just below their melting point. Binder is removed and metal particles are fused to form a dense solid. The production system is cloud-connected. Sophisticated software manages the entire workflow with profiles that are tuned to every build and material, from the printer to the furnace, delivering dense metal parts. The result is sheer throughput. In the time it takes laser-based processes to produce just 12 impellers, Desktop Metal's single-pass jetting technology would have produced over 500. To date, metal 3D printing has been too expensive and too slow to change the world around us. At up to 100 times faster than existing technologies, the production system unlocks the cost per part needed for mass production. For the first time, it's possible to go to market with metal 3D printing.
So that's pretty cool. And I want to show you one more thing from Desktop Metal, which is something that is still, I think, for early adopters. I think companies for a while are going to be focused on traditional designs and how they get parts into production. And it's a very exciting shift. But big companies take a long time to change. You know, you're talking about mass consumer products that need to be very reliable. There's a certain way that engineers have done things for a long time. But I think that's going to change. And this is one of the things that's most exciting to me about 3D printing, is what we alluded to in sort of changing the way design happens and sort of closing that loop. And I want to show you an example of Live Parts, which is a software that Desktop Metal is working on to integrate with their own machines. There are other programs and other companies working on generative design, this idea that basically a computer can create and simulate a design in real time to optimize for shape. This is Desktop Metal's particular version that's meant to work with their system. So it sort of ties design to production, which is really attractive for a potential partner. But I think you're going to see a lot of exciting stuff come from here. And if I were investing further in this space, this is an area I'd pay a lot of attention to. So I'll play this one real quick.
Desktop Metal was founded with a single goal in mind: to make metal 3D printing more accessible to engineers and designers. This means to bring metal 3D printing into the office where the engineer works, and then allow the engineer to take those designs into mass production. 3D printing, especially in metal, is very exciting. And we were finding that our customers were coming to us with all of these great ideas and concepts, but starting with parts that they wanted to print that were in fact designed for alternative manufacturing technologies. And so we wanted to make it easier. We wanted to give the designer a tool that they could use to redesign their parts, or to design their parts from the ground up for additive manufacturing and for functionality.
Hi, my name is Andy Roberts, the creator of Live Parts. I'm a veteran of the CAD industry, going back about 25 years, was in charge of product design for the first parametric feature-based modeler. Live Parts is an experimental project I'm working on to create a generative design tool specifically for 3D printing. The goal of the project is to enable designers and engineers to easily engage with additive manufacturing techniques, to automate the design process and create parts optimized for 3D printing. The tool allows users to import constraints from their native CAD program, automatically grow a part, and export it for printing or assembly back into SolidWorks. It's a totally different approach to the way things are created, because it's not generating many different designs randomly. Instead, it's creating a design by developing it from a seed cell into an organism, and it's optimized for its environment. It's constantly adapting to changes in the environment, changes in the forces, and it creates lightweight parts that are strong and fatigue resistant. While other tools model multiple static load cases, Live Parts simulates transitional dynamic forces, capturing multiple load cases at the same time. This includes interaction of variable loads over time, and this enables the tool to more accurately mimic complex real-world conditions.
We are very excited about our partnership with SolidWorks and this opportunity to preview this new technology to its community. LiveParts is still in its early stages, so while you explore it, we invite you to give your feedback and help guide its development. Thank you very much for being part of this journey.
So and I'll just bring that to life for a second. What you saw, these shapes, I mean, it almost looks like alien objects, This would be really impossible. I don't know if anybody on the webinar does 3D modeling. I've dabbled in some super basic 3D modeling. Just to do, good CAD takes a long time. To do really organic, complex shapes like this is nearly impossible with sort of traditional CAD and design tools.
Yeah.
And so the computer and generative design unlocks a whole bunch of capabilities, but even if you were able to design this, there would be no way to make it. Like you couldn't in the past, produce this form, or if you could, it would be extremely uneconomical. This would be a super complex CNC part that you'd have to produce, or a crazy injection mold, just something that just wouldn't be practical. But with 3D printing, it doesn't care. I mean, the process is indifferent to structure of material. In fact, the less material there is, the faster you're able to print. So to the extent that you can lightweight a part or have it be more organic looking with a lot of voids, that's totally acceptable for the process. And it's really exciting. And so I'll show you just a cool tweak here, which is another type of part that is made using generative design. This is a prototype part. It's a real part printed by BMW for a motorcycle frame. I think it's motorcycle frame. It might be an SAE car. I think it's a motorcycle frame. But you look at this part, and it looks like a bird's nest or bone structure or something like that. And this is printed in metal. And guess what? This part is 30 to 50% lighter than the many parts they'd have to put together in a traditional frame. It could be customized for a particular size rider. It could be customized for particular parts that are going inside that engine. And what's interesting here is you see a combination of an additively manufactured frame piece with a lot of traditional engine components. And I think that's what you're going to see for a while. It's not like the world's going to shift over and everything's going to be 3D printed, but you're going to have some really high value parts where 3D printing and additive manufacturing makes a lot of sense, sort of start to integrate themselves. Think about an airplane. An airplane, any weight savings is huge cost savings over the life of that airplane in terms of fuel. If you can generatively design even something as simple as a seat bracket, and that can qualify to fly on an airplane, and that's 20 or 30% lighter than a traditional seat bracket with the same strength, that's a game changer. And you'll see those on every airline. So maybe in the future, you'll see that, or struts on your car, or parts inside a car, or even, parts inside phones. If you tear apart your iPhone, there are tons of tiny metal pieces in there, little metal brackets and hinges. And those are very complicated to produce. Oftentimes they're CNC'd, which means it's already a computer-controlled process, and it's subtractive. You're taking a large block of metal and chipping away to get to your end net-shaped part. And that's very wasteful. You have a lot of metal scrap. It takes a long time, particularly if you move to higher strength materials. I've heard that future phones, because they want to do inductive charging, are going to need to have glass backs, not metal backs, which means they're going to need to have higher strength, which means they need a steel frame instead of aluminum. Guess what? Steel is a lot harder to mill than aluminum. And if you have to mill a ton of steel, it's going to take a ton of time for millions of phones. So maybe there's a world in the future where even things like the frames of our phones or brackets inside our phones are additively manufactured. So I think we have a very exciting future to look forward to. It's also not just big companies that have access to this. It's individuals. A company that we're invested in and excited about is Shapeways, which we spoke about at length last time, and one I'm very excited about. Shapeways just announced a new round of funding. And Shapeways' goal is to bring the most advanced technology to individuals. So maybe you have a 3D printer at home, maybe you've never touched 3D printing. Shapeways wants to help you. And if you have an idea, they want to help bring it to life. And you don't even need to know 3D design. You could upload a 2D drawing or even describe what you're trying to make. They'll help connect you to a 3D modeler, and they'll connect you to the most advanced 3D printing processes and technologies in the world, so that you can just get that object for yourself. So you could buy something for yourself, or you could make it available to sale for the world. And that's really exciting to me because it enables this future where anybody can bring an idea to life and go into business with their own ideas without having to actually make it themselves. And previously that was something that was unimaginable. You know, if you wanted to go into business making a physical product, you'd have to contract with a factory, you'd have to invest in tooling, you'd have to buy inventory, you'd have to deal with logistics and shipping. And now we live in a world where, just like a digital good, where you could design an ebook and sell it to the world without having to touch it, now you can do that with a product, because essentially it's all digital. The design is digital, the fabrication is digital, it's digitally distributed throughout the world to the most cost-effective manufacturing facility, and then the logistics are handled for you. So you could go into business and be an entrepreneur because of the power of 3D printing, even if you know nothing about the technology. And so that's what's really exciting to me about Shapeways, and they're going to be releasing a lot of new tools in the near future that make it much easier to get involved with 3D printing and 3D design. So it's one to watch out for and one we're excited about. So I think with that, we'll go back to the off the screen share here, and happy to answer any questions. And then I think we'll probably wrap.
Yeah, thanks. I mean, another sort of trend, you know, we work with Voodoo Manufacturing a bit. So, you know, he's spoken in our class as well. So they also have, I mean, they've sort of scaled the model of low-end sort of PLA manufacturing, you know, plastic parts, but they've scaled up. So they now claim they can do up to 10,000, you know, pieces in a couple of weeks. I think they have now 200 printers. So sort of, you know, bringing 3D printing out to the masses, you know, through Shapeways or Ponoko or other platforms. And of course, 3D hubs, you know, which aggregates printers across the world. So a lot of our learners, I think, certainly benefit from that availability of 3D printing.
Yeah, I mean, it's not to be underestimated, particularly on the sort of consumer or prosumer printing side. A lot of the FDM machines, you know, you have a constraint of material and process. It's oftentimes just variations of different types of plastics that are possible, but you can do a lot with plastics. And, you know, it's they're typically a very particular type of process. So there are certain geometries that are a little more complex to achieve. But it is amazing how capable and affordable these systems are to let people start experimenting with these types of processes. And the beautiful thing is, if you get something you like, you can scale it up. You could send it to Shapeways or another printing service. You know, you could bring that part over to a different type of machine that can work with more advanced materials, and all of a sudden, you know, you're printing like real professional parts, and that's an amazing thing. And there are companies that are taking these very low cost but high capability systems and trying to use those to be able to do rapid prototyping and scale production for folks. You see Form Labs, which has a different type of production process, a SLA based system, and a SLS system now. You know, those machines are being used in production type processes now, which is very exciting. And yeah, it's a very exciting time. And if you are just getting involved with this industry or have been involved for a while, I think it's a great place to align yourself with from a career standpoint. If you're an engineer or a designer, there are going to be many, many more companies and a lot more demand for these skill sets as we move forward in the world. So if you're early, and I still think it's early, if you're early and you're spending time here, your skills and your products and your learnings are going to be of real value to the world. So I highly recommend you stick with it, even if it's challenging.
So I know some people are asking questions. Some questions are coming up around the kind of software, you know, for starting out. So I've answered some of those. And those of you, we do get quite a few educators in the space. So yes, as James, who's at UT Austin, pointed out, most of these packages have educational versions. We use Autodesk all the time, and all their software is free for pretty much anyone, not just students. And particularly, I guess, to, you know, to bring it back to the examples that Zach just shared about. So I guess the next frontier is, generative design, and now that is is now being bundled in with SolidWorks. I know Autodesk is also doing a lot of work on generative design. So I guess for the next frontier is to learn those skills, after you learn the basics of modeling, or if you're an educator or, a design shop, I guess generative design, and then metal printing. So are there, Zach, one question for you. Besides of course, metal is getting exciting, more cost effective on the desktop, literally, and generative design. Any other trends over the next couple of years that are exciting?
I think two things. One is true commercialization of parts. You've seen historically 3D printing has been expensive. It's been for a wide variety of reasons, but just an example, even in plastics, desktop 3D printing is a slightly different story because they're using commodity plastics. But for something like SLS, which is a more advanced process, laser-based, they require a special powder to print. That powder, that material in bulk is, let's call it $20 a ton. But the particular size powder you need for 3D printing costs 10 times that much, $200 a ton. And it's because only a few people make it, and they can charge a lot for it, and they have to build special factories to get it to that precision powder. Those numbers aren't accurate, but they're just for example. It's roughly a 10x difference. Well, guess what? Because 3D printing is growing and a lot more companies are using it, those new companies are starting to make those materials, and companies that are in it are expanding production, and the price is coming down. And so you have a major trend where prices across the board are just coming down. There's more competition on machines. There's more competition on materials. Volumes are growing across the industry, and that is a trend that will continue. It's just the nature of economics. More competitors, more scale, more efficiency in the system. Prices are going to come down, and that trigger, every time you see a price lowering, it triggers some new possibility, right? Some new capability. So that's really exciting, and that leads to more commercially realistic ambitions for this technology and a lot of new commercial parts. I think, so the materials is one side, the cost of materials, the cost of processes, and also the expansion of materials. You're getting materials that are getting qualified for aerospace, getting qualified for automotive, materials that have been qualified, both plastic and metals, that have been qualified for medical applications, like implants. That's really exciting. These are very high value applications. Even if something costs a lot at first, it still has high enough value to make sense commercially. And so you're seeing a lot of this commercialization happen. The other thing I think is design tools broadly. I wouldn't just say generative design. There have been a whole assortment of new types of design tools that are coming to bear. And at the same time, there's all sorts of new 3D sensors and new ways to capture and generate 3D data. I mean, people spend, especially like teenagers and young people, can spend a third of their day living in fabricated 3D worlds, playing video games and building things in Minecraft and other types of universes. Guess what? Those are all 3D assets, and there's no reason that you can't take those 3D assets and make them real. And so there's all sorts of new 3D content that people are starting to explore printing. There's a company that's been very successful on Shapeways, using Shapeways as a platform called Hero Forge, that takes game characters and prints them for people. And these are characters that people have spent a really long time developing and leveling up and getting all sorts of accessories for, and they're proud and they want to showcase it. And they built a great business helping people showcase that as a literal trophy. And there are so many digital assets that can be printed. This phone, this is the iPhone X, this has a 3D sensor on the front of it, right? It does for Face ID, it has a 3D sensor. There's no reason that 3D sensors aren't going to be more prevalent on phones and be repurposed to enable people to do 3D scanning in the world. I think we're going to see a lot more 3D content. There's AR and VR. All of those things require 3D assets and 3D depth sensing to sort of work in the world. And those all play into 3D printing. We're just going to have more software and more assets and more capability around 3D design and interfaces. And at the same time, I think just design tools that make it really easy to create in 3D. There's been some amazing, I don't know if people have seen Google's Tilt Brush in VR, but it's like a 3D design experience where you're in virtual reality and you're literally using your hands to model. It's a very organic, sort of sensual way to design. It's very different than, clicking with a mouse and trying to extrude and carve away a 3D shape. If you can just sort of mold something as you'd like it to be in 3D space and it feels like it's in front of you, that's really powerful. So I think a lot on the design side and then a lot on the materials and cost side are sort of two big drivers to pay attention to.
Right. Okay, thank you. We have some questions. James was at UT Austin asking about applications for AI in monitoring and adjusting the printing process in real time.
It's a great question. I'm sure there are applications there. I haven't spent a lot of time with it. To get very high quality, very reliable parts, you need to have good process control. I don't know if that's AI applied in real time to the process itself or post-process when you analyze parts to understand what's in tolerance, what's out of tolerance, and then how to change sort of the design instructions that are sent to printers over time to get the results you need. To have good AI, you need a really good data set. And so the question is, what's the data that you're gathering on the actual print side that's useful? Most printers today don't have many sensors built in besides temperature and position, right? Maybe some of them have a camera, a visual sensor. I think you would need some type of very, very highly optimized sensor to close that loop so you could get really good design optimization. Desktop Metal is doing this on the heating side. I don't know if they're using deep learning or artificial intelligence, but on the heating side, because they need to get very consistent heating to fuse the parts once they've been bound by the powder, then they're using a closed loop system to be able to measure that temperature in real time. And over time, maybe there's an artificial intelligence system that is put in place that allows them to better optimize how objects are heated based on their shape, based on design parameters, based on density, as that model learns what works best. And I think you'll see the same thing probably for printing over time. But I still feel we're a little ways away from that because so many of the machines are just about making something work at scale and not yet about the ultimate optimization that comes from sort of an artificial intelligence system in the production process itself.
Nice, okay.
And if you think about the types of customers that are using these machines, they want consistency and reliability, and they want to know that what they put in is what they're going to get out. And so I think designers and machine makers are thinking very carefully about that. And if you have a more dynamic system that is sort of optimizing in real time or changing a lot of things, if something changes on the fly and that results in a part that for whatever reason isn't exactly what you expected, that could be a big challenge for ultimate end customers. But if that process and software is used to make something more consistent, then it could be of value.
Nice. Okay. Ashok has a question about, is this technology relevant for printing solar panels or perhaps solar cells would be more accurate?
That's a great question. I don't know is the answer. The skepticism I would have, or the critical question I would ask, really relates to materials. Because if you think about what a solar cell is, most solar cells are very highly refined forms of silicon, which are created in a very specific way. It's sort of how we create semiconductors. It's a material that started from a single crystal and a seed and then grown in a furnace to very high purities and then doped a particular way to sort of create the junctions that you need to create an effective photovoltaic cell. I don't know what the advantages would be to 3D printing a solar cell unless there was some advantage in geometry, but you'd still have to overcome the materials limitations, which today sort of define the performance of a solar cell. It's are these materials the most optimal materials for capturing sunlight? And then there's sort of marginal gains around the edges of how those materials are put together and how they're layered and packaged. But a solar cell is an assembly of, one very, very, very pure, precise material, and then, interconnects and inverter and glass panels and frames. And I don't know how 3D printing would affect that. I think 3D printing for the foreseeable future for commercial applications will be more relevant for objects that are made from a single or maybe two materials, not many, many materials combined into one, because those processes are all very different. And so it can be challenging. You could have good alloys, but a single alloy, not not many alloys mixed into a single process. I think that'll be a long time before people get comfortable with that and the machines are capable.
Nice. Okay. Well, I think that's a great set of overview of what the future is. I guess the present and the future of the trends in 3D printing. So with that, we'll call it a wrap. And Zach, thank you so much for taking the time.
Thank you for having me, Vishal. Good luck, everybody. Thank you for joining. Thank you for the good questions and for hearing me out. Have a good day.
Thanks. And thank you to all the viewers. This video will be available in the course website on Coursera and also on our YouTube channel on 3D Printing Profs. So look forward to having you back in the courses. And I guess those of you who perhaps on Facebook might not be in the course. So if you haven't already seen the course, check it out, Coursera, and just search 3D printing or 3D printing profs. .com. That just type the URL there. So thank you, Zach, again, and look forward to chatting with you later. Bye-bye.